Thank you everyone for waiting. And once again, good evening to all of you who joined in. And today we are diving into the real-time intelligence with Microsoft Fabric. We will explore how to harness real-time data processing using International Space Station as our case study. So in this session, we are going to see how to use Microsoft Fabric's Python, PySpark, notebooks, event streams, and KQL databases with Power BI to capture, process, and visualize live ISS data. So it's my pleasure to introduce our presenter for the day, Nalaka Wanniarachchige. And Nalaka is a senior data analytics consultant at Digital team. He is an accomplished data analytics and data engineering professional with over 18 years of experience. He is also a CIMA qualified ex-banker and a Microsoft certified Fabrics analytics engineer, and he also specializes in Power BI. So he's coming from a very strong analytical skills background and robust data solution building skills. Um, so he's helping us build advanced analytics and top-notch data solutions for our clients. So Nalaka, without further ado, I will hand over the session to you.
Yeah, thank you, Imali. Uh, Hello, everyone. Good morning, good afternoon, good evening, wherever you are joining from. So, welcome to the session. Today I'm going to walk you through something really exciting, real-time intelligence with Microsoft Fabric. So, you might already have heard about bit about Fabric, but today I'm using it in a fun, practical way, tracking the international space station. So we will look at what kind of information we can pull, like its current location, details about the astronauts on board, and some other cool stuff. So this session is all about building something useful and hands-on. So it's not just about theory. So I want you to walk away with ideas you can use in your own projects, right? So actually, Fabric real-time analytics, real-time intelligence capabilities are not talk about enough, but they are incredibly powerful. So let's dive in and see what we can do with real-time analytics. So a little bit about myself. First of all, who am I? I am Nalaka Wanniarachchige, currently working as a senior data analytics consultant at Digital team. I have been working in the financial industry and BI space nearly now 18 years. So mainly across the full data life cycle from integration and modeling to analytics and reporting. Most of my work has been around tools like Fabric, Microsoft Fabric, Power BI, Azure, Oracle BI, and traditional, the data warehousing, helping both business and tech teams making better use of their data. So outside of work, I am a father of two kids, and whenever I get a bit of time, I enjoy sharing uh, ideas and ideas and projects that I have worked on in the data space. Through my blog, I have a blog named bidiaries.com, so feel free to check it out if you are curious. And also feel free to drop any questions regarding this session in the Teams chat during the session. So I will go through them at the end. During the Q&A time. Okay, first thing first, what is Microsoft Fabric? Fabric is kind of a, so all of you know the SaaS platform, right? It is a umbrella of services, SaaS platform that comprises many workloads. So you can see in these slides, data factory, analytics, databases, which is very recently released. And our focus today is real-time analytics. And you can see AI, OneLake, and Purview are powered the Fabric, Copilot for the AI, and OneLake is for the one copy of data, and Purview for the data management and data governance. Uh, so if I try to explain all of these workloads and give a introduction to the Fabric, it might take more time. Because of that, I have narrowed down my focus only onto the real-time intelligence part, right? Okay. So what is the main questions that we are what we are having when we are dealing with the real-time data? I mean, time-oriented data. It is, as you know, it is highly volatile, right? And also low latency and highly volatile data. We cannot uh, manipulate the data with our traditional methods. If let's say if you are familiar with SQL or Python or whatever the language you are using, uh, that uh, that languages are not enough if you are dealing with the real-time data. So you need a new tool set in your tool belt in order to handle this kind of a data, because once you have started to work with the time related data, within seconds or minutes it is stale, right? It is the data is old. So your insights or whatever the reports you are building out from this those information are no longer valid. Because of that, we need a different kind of a tool set. So that's the main problem that we are having. So you can, in this slide, you can see the real-time intelligence. So actually, when Microsoft first released the real-time intelligence, sorry, the Microsoft when Fabric first released over 2 years ago, it was released as a real-time analytics. So the real-time analytics and also the data activator as two separate workloads. After that, recently Microsoft coined the name real-time intelligence by combining both these workloads. So the real-time analytics is powered by event stream, event house, and real-time dashboard, and data activator is powered by the reflex. So uh, so you might ask, what is event stream, event house, those two. So the event stream is the heart of the real-time intelligence, we can say, because event stream is kind of a interface that talks to the data sources and then do some transformation and then send to the destination. Much simpler way in order to understand. So but this event stream is I mean, it can work as active and passive way both. So that means this can pull the data from the data sources, and the data sources also can push the data into this event stream as well, though this is more enhanced. So earlier Azure also had Azure Analytics, I mean the IoT real-time analytics as well. But in Fabric ecosystem, Fabric it has more enhanced, and the capabilities are now moreover simplified. So most of the technicalities and all the connections, most of the things are abstracted. So you don't need to worry about bringing all these workloads into a, I mean, uh, by connecting all these things, because you need to you need to focus on your building your real-time solution. And the event house is kind of a event house is the place that houses all the KQL databases, right? So the KQL, if you are not heard about KQL, it is called as the custom query language, which is optimized and highly optimized for the real-time data. So so because when you are working with the real-time data, the SQL and if you are familiar with SQL or the normal languages are not enough. So you need a better tool for that. The uh, KQL is the engine that is powered by inside the event house. KQL is the engine that is powered by data transformation for that database. So this KQL can handle millions of billions of data within super fast speed, because it is a highly optimized, highly compressed engine inside the event house. And a real-time dashboard, this is somewhat similar to a Power BI dashboard, but the two fundamentally two different architectures when it compared to the real-time dashboard and a Power BI dashboard. Real-time dashboard also gives, I mean, real-time dashboard have a lesser capabilities when we compared with Power BI dashboards. Uh, uh, because this is more of a simple visuals that we can, I mean, create insights. So some of the visuals based on that inside the event house. The reflex is kind of an automated responder, we can say. It watches the data as it arrives, and in real time it reacts instantly based on the rules that you are going to define. So it's simpler terms, you can say it as like a smart robot, right? Let's say you are monitoring a sensor for high temperature, so we can define a reflex rule, let's say For an example, if temperature exceeds 70 Celsius, for an example, we can send an alert and save the data in the destination as the way we want. Right. So this is another representation of the real-time intelligence components. So you can see these are the data sources, and we can the data sources. Then we can ingest and process inside the event stream, and then we are sending those into the event house, and this consists databases and tables, and we can act upon the rules we are going to define. And there is another important component here, KQL query set. This is the query pane that we can write out queries. Let's say the similar to if you are using the SSMS or Azure Data Studio, you can write out the queries inside the KQL database using these KQL query sets, and you can save them. Real-time dashboard we have discussed, and all these are powered by, I mean, the data is stored in the one lake. So event stream. So event stream, I mentioned earlier, this is the heart of the real-time intelligence engine. So you can see inside the event stream, there are three protocols we can see: Event Hub, AMQP, and Kafka. Uh, these three. So we can use whatever we I mean whatever the protocol that we need according to your use case, and then we can do some of the transformation. This is a actually event stream is not sending the data into one-to-one copy basis into the destination. We can do some of the transformation upstream, and we can send the data into the destination. For an example, this is in our use case, we are sending our data into event house. So the beauty of the event stream is Microsoft Fabric event stream is these are actually no code based solutions. If you even don't know the KQL or the syntax, you can do this in without much effort actually. And we will see in the coming slides how we can utilize these functions. And as I mentioned earlier, these are the sources and destination in the event stream. So you can see most of the sources are currently as Azure Event Hub and IoT Hub sources. But you have CDC change data capturing, and also workspace fabric, workspace events, and Azure Blob storage events, as well as the data sources. In our example, in our use case, we are using a custom endpoint as our source, and also for the destination, we are using event house. I have written out a blog regarding the both the sources and destination. Both are custom endpoints. It's a really interesting use case. If you are curious, you can read it out, because the event stream can work sometimes in dual manner in this case. But for our use case, I am using custom endpoint and event house, right? Okay, so this is the simplified iterate architecture. So actually, this is very simplified architecture. If you are, so actually, what we are going to do now is we are going to get the data from an API. So we are using three APIs, and then we get the data from an API. Then we using that API, we are executing a code block inside the notebook, uh, and we generate the payload. So the payload is then sent into the event stream, and then we save the data into the event house, and also that means that we are saving those in a tabular format, and then we can visualize the data as whatever the way we want. So in this case, I am using Power BI. But if you need to expand your solution, you can I mean you can use the reflex activities as well. So actually you can see how simplified this one, right? So in the Azure scenario, whatever the different technology if we are going to use, it is a more complex one, because we need most of the time we have to spend the time to connect in the services. I mean, correct configuration of APIs, all the things, right? So now I will. This is a kind of a session which is more demo heavy, and in order to save time, I actually pre-recorded some of the slides, because this if I try to explain all the things that is happening in this session, it would take more time. Because of that, I have pre-recorded. After the pre-recorded slides, I will go into the Fabric workspace and explain the other stuff in very detailed manner. Right. So what we are going to do first is we are going to create an event house. So what is the purpose of the event house? Event house is a place that we are going to save the table, right? We will see how we are going to save the table. So first, for the people who don't know about Fabric, this is the Fabric workspace. This is a blank workspace, and then we are going to create an event house. How we are going to create an event house? We click the new item button, and then we select the event house. As soon as we click the event house button, create button, we give a proper name for the event house name. We give ISSDB001, whatever the naming nomenclature you are following. And then as soon as we click the create button, you can see automatically it landed into a canvas that consists KQL databases. So once we create the event house, it is automatically creating a KQL database. You don't need to configure anything; it automatically created. So inside this KQL database, we are going to create the tables. There are other technicalities regarding this area, but for our use case, this is sufficient, right? So the second one is we are going to create an event stream. So event stream, as I mentioned, this is the heart of the real-time intelligence. So we are going to create an event stream. Similar to the previous step, we select new item and then type the event stream and we give a proper name for the event stream. So this event stream for the geolocation data. So remember I mentioned uh, I mentioned we are going to create 3 event streams, but this one is for the geolocation, right? So once we create the event stream, it landed into a page where we can select the data sources. So I will explain this slide more detail. So you can see in here we can select the external sources and as well as custom endpoint. So these external sources are the sources that I have showed in the one previous slide, that Azure CDC and also the IoT hub. But for our use case, this is the endpoint that we are going to get the data, because we are going to talk to an API, right? So because of that, I am going to click this custom endpoint and then create a custom endpoint, right? In next slide, we will see how we are going to create a custom endpoint, right? So after I click in the custom endpoint, I am giving a proper name for the custom endpoint, and then I click the add button. So in this screen, you can see here. So this is the event stream. This is the event stream icon, and this is the custom endpoint. This is the custom endpoint icon. So as soon as we click the add button, custom endpoint automatically created. So now what we are going to do is the custom endpoint. The usefulness of custom endpoint is we are trying to get the connection string of the custom endpoint, and then we use that custom endpoint connection string and then use it in our notebook. That's how it works, right? So then when we press the publish button, and you can see now when we click the this custom endpoint, there are three protocols. There are three protocols inside the custom endpoint. So you can see Event Hub, AMQP, and Kafka. In previous slide, I have mentioned this. So what we are going to get is this one, SaaS key authentication. We click the SaaS key authentication and we grab the connection string primary key. It doesn't matter whatever the key you are going to take. I mean, secondary key is also fine, but I am taking the primary key and I copied it and then note it down, right? So after that, the key I have copied, I am using inside the notebook. Let's see in the next slide how I am going to do that. So in this slide, I am going to create a notebook. So this is the most important part, because this is the area that we are going to use the Python. So after I select the notebook, we give a proper name. We give a proper name for the notebook. So if you are familiar with Jupyter notebooks, this is somewhat similar. This is the notebook experience that we are having in the Fabric. So we are giving a proper name for the notebook, and then we select the language we need to select, and we connect to the session. Uh, Other things are okay, but the main thing is we can select the language. Actually, for this one, I selected PySpark, but since the payload is very much low, you can use the Python as well. Then what I'm going to do is I'm going to install some of the libraries. So in the code block, first code block, I'm installing these two libraries, and I have written out the code. This code is written by me, and this code, what is it doing is it generates the payload. So how it is going to generate the payload? You remember in the previous slide, custom endpoint, we have copied the connection strings, right? In this line number 9, this is a place that I'm going to paste that connection string into here. And the API URL, the most important one, this is the API URL that we are going to get the data from an API. I will show you how this API looks like after I finish these slides. But these are the two parameters that we are going to use. Other things are kind of transformation of the data. I mean, adding the date column, those things. The most important one is these two. So remember, I told you we are going to create three event streams. So in all these other event streams, only these two parameters are going to change. I am going to create another event stream and then create a custom endpoint and then copy the connection string into that new notebook, and the API URL is different. That's the pattern that we are going to follow, right? Okay, then we first we connect to a session and then we execute the notebook. You can see first we install the libraries. Libraries have been installed, and this is the code block that I have mentioned. So this is the URL. ISS now is the location, is the API for the geolocation, and this is the connection string for the um, uh, custom endpoint. So then we execute. So you can see it is sending the data into the event stream, right? So this data is pushing through into the event stream. So now if we go into the event stream, now if we go into the event stream, we can see the payload is coming up. So if we refresh the page, you can see the data is popping through. Yeah, in here you can see the data is coming through. So if you think about this, the payload we are generating, actually the API URL is sending us is a JSON. It's a JSON output that it is sending. But once it landed in the event stream, it is tabularized, right? You can see if you think about this, if we try to this in our let's say SQL, we can do that. I mean, converting JSON into a tabular format, we can do that. But the effort that we are trying to use, I mean, the effort we are going to use, I mean, utilize is very much high, right? So because of that, I mean, the event stream facilitate very much flexibility to do the data transformation very easily. And if you notice in here, this ISS position column is a JSON, is still a JSON format, right? So the most important important information that we need to get is latitude and longitude in here. So how now I need to split this out into two columns. I will show you without any code with the capabilities inside the event stream, we can split this column out, right? We will love this. So if I play this now, so we have other data. Okay, those data are fine. Right. So in this one, we are going to configure the destination table. This is a place that we are going to manipulate the data into two columns. So what I'm going to do now is I go into the event house and select the KQL database. So what we are going to do now is saving the data into a table, right? So for that, I select the KQL database and then press the get data button. Okay, right. After I press the get data button, I am going to select the event stream that we are going to create. So, and also I am going to give a proper name for the table according to the naming convention that you prefer. So this is for the geolocation table, right? And also we are going to select the workspace and select the event stream that we have created in earlier steps. And also the connection. So the data connection, it is automatically created. You don't need to worry about that. Then if I press the next button, you can see, so you can see the data is coming up uh, as per the event stream data. So this is the data that we are going to save, right? But remember, I have mentioned this column. So I mean, we cannot derive a proper insight if the data is lies like in this format, right? It is latitude and longitude in one single column in a JSON, I mean, within these brackets. So how I'm going to do this? There are two ways. We can manipulate transform this data inside the event house. I mean, using the KQL query language, we can do. Other one is we can do this transformation inside the event stream. Maybe I mean the event house. By increasing this nested level into two, we can split out this column into two columns. Let's see how that is working. So now I'm going to increase this one into two. So see, now it is splitted out. I will focus on this column, and if I split it out into two, that column is separated out into two. I mean that column is separated out into longitude and latitude. Also, if you are interested, you can see the code that is generated, right? So these are the two columns. These are the two columns that I have split out, right? And also you can change the data type if you want, or else you can do that change in the uh, table level itself. Right, this is the code that is generating the DDL that is automatically generating, and then we are going to save this in. We press the finish button, and it will automatically save inside the event house. So you can see this is the table, right? This is the table that is saved. We can see the data. I mean, if we refresh the page, we can see the data. Let's see how that looks like. So now I refresh the page. You can see the data, right? So you can see so that you can customize the day, I mean the data interval according to these parameters, and you can see this light green colored one, right? These are the actually the real hot data that is coming through at the time of this recording. So this data is actually the real data, not the near real time. These are the actual data that is coming through that event stream, right? So we have created one event stream, and then we have created one table based on that. In similar fashion, as I mentioned earlier, we are going to save the astronaut details from another API. We will see uh, that also. So what I'm going to do now, I'm going to create another event stream, give a proper name for the astronauts, and it will create a new event stream. And then we create a custom endpoint similar to the previous steps and give a proper name. This is the second iteration that we are going to do the create a event stream, right? We give a proper name for the source, and then you press that button. So it is landed into this area. So we are now we grab the connection string of the custom endpoint. Just publish that, and then get the connection string of the custom endpoint. We click here, and then take that. Then we use that in our notebook. What are the two parameters that are going to change? This connection string is a new one, and the API URL is a new one. That's the pattern that I have followed for this use case. So now I'm going to create a new notebook. Give a proper name for the notebook, and then first install some of the libraries. These libraries, And then the second code block is similar to the first one, only changing is those two parameters. First execute the libraries installation. Yeah, okay, the libraries have installed on the second code block. In line number 12, in this line number 12, we are going to add the, yeah, if I post and and here, this is the new connection stream that we have copied, and also this is the new API URL that we are going to get use. So the for the Astros, it is astros.json, new API and new connection string. Others are same. So we execute this and then we generate the payload. This will be sent into the astronauts event stream, and we can utilize that data. So then it is started to send in the data into the event stream, and if we go to the event stream, astronauts event stream, we can see the data. So we refresh the event stream. Depending on the data volume and also the sometimes the speed of your internet, it takes a couple of seconds. And you can see here very interesting thing. So you can see the similar to the previous scenario, the data is coming in like this in columnar basis. But in this people column, similar to the previous one, it is also it is uh, with parentheses. We need to split this out. This time I'm not going to use the event stream. I'm going to use the KQL language. We will see this one how it goes. So then we need to save this one, right? So I go to the database and then give a proper name for the table first, and then select the event stream that we have created. We give a name, proper name for the table, ISS astronauts table. Select the event stream. It's astronauts, right? Connection is automatically created. Yeah, this is the column that I have discussed. I have mentioned. So this is the column. You can see there are two crafts in the International Space Station. One is ISS, other one is Tiagon. So we need to identify craft and the astronaut's name in two different columns. But this time I am not going to do this inside the web stream. I am going to use the KQL. You will be amazed how simple the language that syntax that we are going to use with the KQL. Right. So then we press the finish button. The data will be landed into that table. Right. You can see here ISS Astros table. This now having the data in the format that we have showcased. So now from here onwards, I will go into the Fabric workspace and explain other steps. So now you are in Fabric event house. So these are the three tables that I have prepared. So remember these two tables I showcased in my session, but this table creation, it is similar to the previous step. The only change is we are using a different API for that, right? But the other things are similar. Only change is the API URL and the connection history. So if I show you what is the API looks like, you can see here, this is the ISS now, the current location of the ISS. So we can see the data in here. So we get the position data, I mean the latitude and longitude data using this. And for the velocity and the altitude, we are using this API for getting this data. And for the astronauts detail, I am using this API, this Astro JSON. You can see this is a JSON, I mean, nested JSON. Uh, the data is having as a nested JSON format, right? These are the three APIs I am using. But if you have a one API for your related topic, you can use a one API, and also you don't need to create a three event streams like I have done here, right? So then we have these three tables. Now what I'm going to do is I am going to use the KQL query sets. I remember I have mentioned the query set. So this is the query pane that we can write out queries. So for this one, I need to write out four queries. So using these four queries, I am going to connect into Power BI and then generate the visuals. So first I will explain what I'm going to do with this geolocation table. So the geolocation table is this one. So this is the KQL syntax, right? This is first it starts with the table name. I mean, if you are familiar with SQL, it is very much different. So the table is not coming in this KQL. It is starting from the table name. So what I'm going to do with this query is I'm going to get the first 100 timestamp of the trajectory of ISS. I want to get the 100 time points. If I execute this, so you can see latitude and longitude are coming up with the timestamp that I have that I prefer. If you need to see a visual format inside the event stream, inside the event house, you can add this render scatter chart with kind map. Then it will automatically create a visual, right? But as I mentioned earlier, these visuals, the dashboard visuals inside the event house is so far it is not much appealing. Let's say do the basic job, but if we generate this kind of visual, we cannot see what is the location, right? Because of that, so because there are no tooltips, those things, it for the tables visual is it is fine, but for the map visuals, those things, it is still evolving. Because of that, I am going to use the Power BI. So Power BI have more capabilities. But if in your project, if that is sufficient, then you can generate that and then pin into a dashboard. Remember, I mentioned earlier there is a dashboard component inside the event house. So if you need, you can plug this into a dashboard and utilize this. Right. So our first query is fine, and then the second query I'm going to get is I want to see the last 90 minutes location of the ISS. So for that I use the this one ago 90 minutes, and similar manner I am using the kind equal map. So if I execute this, I can see a uh, I can see a visual like this. I will show you this more clearly when I plug this into the Power BI. But for inside the event house, we can see this kind of a sine wave that ISS has traveled. Right. So the astronauts, remember, this is the more interesting one, right? So the data we are having here is still in this format, right? In this column, it is like this craft ISS. This is kind of a uh, this is a kind of a format that we cannot use in our visualization, right? So because of that, I need to uh, properly manipulate the data. So what I've done is I have used these two lines. That these two lines are doing is what it does is MV expand, MV dash expand people is the column name, and I want people and craft separate out. So if I execute this, see the magic. It is split out the data into nicely into different columns. So actually the KQL syntax is sometimes it is amazing. So we don't need to, I mean, we don't need to use complex syntax in order to deal with the data. And also the speed and altitude. If I execute this, we can get the data using this table in the similar measure. Okay, the most important one, let's say you don't know KQL. You want to formulate a solution. So regarding this one, let's say I want to get the speed and altitude, but you know SQL very well. So I have write out this SQL, right? This getting at actually the first uh, record from this table order by timestamp descending. We all know that. So if I execute that, So we get the same result. So then you might ask, what is the purpose of using the KQL inside the event house rather using the SQL? So the point is here. Actually, you can use the SQL, but event houses are more optimized for the KQL language, because it is so because of the uh, I mean the nature of the data, because the data is highly volatile, and also the low latency of data, because depending on your data volume. So in my case, this is a one single row, but let's say you have millions of billions of data, and if you want to manipulate those with the SQL, then it is not much optimized. Because of that, always recommend is to write out the KQL. Okay, so back to the question. So I don't let's say I don't know the KQL. Okay, but I have written out the SQL. By using this explain keyword, I can convert this query into a KQL query. So if I write it out, so you can see this is the query that that is a corresponding KQL query that we need to use. It has a small change, but this is the query, right? So you can see the possibilities with the uh, real-time intelligence, right? It facilitate the your SQL experience into SQL skills into a next level using these short methods. And if you further want to study out with KQL, there is a there is a course that is published, like mentioned as the KQL Detective Agency. There is a certificate. It gives out a certificate too. So it is a kind of a detective that is trying to solve the problems using the KQL. So try it out. So it's a really interesting course that if you are curious about the KQL, right? So we have these queries. Now I am going to plug those into the Power BI. So if I now open the Power BI, so this is the end result. I will explain this one after I explain these steps. So if I click the edit query, so how I'm going to get the data from the event house. So for example, what I'm going to do is I'm going to select the custom. Actually, this connector is not a new one. This was there from, I mean, a couple of years back also. So this is not a new one. So we use the Azure Data Explorer cluster connector, and we need to pass a cluster URL. So how I'm going to get the cluster URL? Uh, I go to the database, and then inside the database, there is a, we can copy this one, query URI. This query URI is the one that is corresponding into the cluster. So once we copied that, and then uh, we pasted here, and then we give the database, and then we pass one by one queries that we have created on earlier steps. So this is the thing that I have done for this one. For the location, this is a cluster that we have copied from the database event house, and uh, this is the query that I'm going to use for the location. So you can see ISGL location and for the top 100 rows, right? In similar fashion, for the astronauts, I paste the query that I have created and then execute here. Further, if you need to do the transformation on downstream, you can do with the Power Query, right? There is no harm. There is no restriction for that. For the orbit, in a similar fashion, I want to see the 90 minutes trajectory. I use that query, and for the speed and altitude, that's similar to that, right? After that, I use these thing into this. I prepare a report. This is a ridiculously simple report, but the point is not about the report, the capability here. So you can see I have set up the uh, page refresh in this one. So you can see it is moving, right? So you can see the altitude, the speed, and also the time. This is UTC 0 based. And so if you need, you can add your time at the time as per your need. And for the orbit, if I click the visual, you can see this is a trajectory that is last night. Since I have started this one, couple of hours earlier. This is the trajectory that it is showing. So this is the now it is traveling above the South America. And also the astronaut details. These are the astronaut details that we obtain those data, and also the altitude and also the speed. It is 27,571 kilometers per hour. It is traveling. So can you imagine that speed? I mean, actually, obviously this is relative, right? The astronauts don't feel that kind of a speed, but when compared from the Earth surface, it is a very fast speed, right? And also a little bit about history about the space station. It is now 25 years in orbit from its and after it's sent out to the space, and also the so far 270 astronauts visited. So there are many interesting facts related to this international space station. So if you are interested, you can read it out. And then what I have done is I have saved this report and then published into the Power BI service. So if you go to the Power BI service, you can see the same details as we saw in our uh, in our Power BI desktop. Okay, we have prepared the report. So how do we validate the report? Is this correct? So there are numerous websites that we can track the International Space Station. So this is a one such kind of a website. So let's see our report is correct. It is showing the altitude 420 and speed is 27,575. Okay, let's see. Yeah, speed is correct. Altitude is correct. And the location, it is traveling near, yeah, in here. So in our visual also, it is quite similar, right? Right. So this is the end result. But you see what is the how much of capable that real time intelligence now, right, inside the fabric. Back to the presentation. Uh, So these are the queries that I have used. All these queries are in my blog post. I will paste. I will share this one in the chat window. So you can change these ones and I mean utilize according to your project. And another thing I have to mention, these kind of solutions we can use. We can build it using Azure Logic Apps, as I mentioned earlier. So, but it is not free, right? So, and also it is not straightforward. I mean, it's a kind of a template. So the flexibility to change that is somewhat cumbersome, right? So regarding further references, there are many resources outside there. Especially the Microsoft Fabric provides more documentation regarding the real-time intelligence. So if you are interested, you can read it out, and we can use this kind of capabilities for different use cases, right? Uh, so this is a small video. This is small video that astronaut shows out the how the honey looks like in this space. So this video contains no sound, but so you can see it's honey, right, in the space. He tries to show out how it looks like in this space. So all right, that's been it. I think I have covered everything. So thanks so much for sticking with me throughout the session. I hope I gave you a good overview regarding RTI. Now the floor is open for Q&A. I also take a quick look in the chat window while you are raising the questions.
Thank you, everyone. The floor is open for questions. If anybody has questions, we can answer those, Nalaka is happy to do so. If not, we can wrap up the event for the day. Nalaka, I suppose there aren't any questions. I believe you have explained everything quite well so far. And we owe you a huge thank you for delivering this session today. It was very fascinating to see how you retrieve those data using Microsoft Fabric and the other tools within the platform. So thank you once again to you and to everyone who joined in us today. I believe everyone who attended found this session valuable and insightful, and you'll be able to use this in your work, obtaining real-time data and data processing in your own projects. So if you have any further questions, and if you'd like to continue the discussion, I'm sure you can follow Nalaka in the platforms he has shared earlier. We'll be sharing this live recording of this webinar in our YouTube channel, official YouTube channel of Dijital team.